Okay, in this section, part 3 of 4B, Similarity and Congruence of Triangles. This is the third page. Even though it says it goes to pages 1 through 9, 6 through 9, if you look, these are all video links, which I have included in your Canvas for you to look at. So that part you are doing on your own. So third page here, similar and congruent figures. Two figures are congruent if they have corresponding angles of equal measure and lengths of equal measure. That sounds pretty simple in explanation, but let's see what we have here. Example 1. Megan purchased 2 rectangular shaped tablecloths, each with a different design. The tablecloths each have a length of 8 feet and a width of 4 feet. What can be concluded about the tablecloths? And we're looking at the answers. Here, 2 tablecloths are not congruent, 2 tablecloths are congruent. The corresponding angles are not congruent. There's not enough information to make a conclusion. I think we can safely say the 2 tablecloths are congruent, which is the highlighted part here. So let's look at this next example. 2 shapes are similar if their corresponding angles are equal and their corresponding line segments are proportional. So, okay, this gets a little wordy here. So triangle DEF, that is the larger angle, is similar to triangle GHF, which is the smaller triangle inside of it. DG is 12, GF is 25. GH is 10. What is the side length of DE? So you're looking at proportions. You would use the proportions of the first 2. Let's see, GF over DF equals GH over DE. So the way to get DF is DG plus GF, and that equals GH, let's see, GH over DE. So here they put in the numbers, 25 for GF. The 2 numbers DG and GF are 12 and 25, which make it 37 centimeters on the bottom. 10 centimeters for the length of GH. So this is a simple solve, cross multiplication. DE times 25 equals 37 times 10. You got 370 centimeters divided by 25 equals DE, which then comes out to 14.8 centimeters. So what is the length of side DE? So this is 14.8. So let's take a look at the next example here. Example number 3. The shadow of a 24-foot tall post is 6.4 feet long. At the same time, a tree casts a shadow that is 4 feet long. What is the height of the tree? This is all about proportions. So they use the height of the tree and the length of the shadow, and then the height of the tree again over the length of the shadow of the second tree. So you got 6.4 times x equals 24 times 4, and that's 96 foot square. That you do, what is it? Divide out 6.4 across the equation, and then x comes out to being 15 feet square. So these are just examples. So I hope you got something out of those. So, and we are done with part 3.